In this particular lecture, we are going to discuss about basic process control system or closed loop system and how the closed loop is represented in the P&ID. We'll be taking an industrial example to show you how the flow, level, temperature loops are represented in a P&ID. So going back to our earlier example, if you see here, this is the furnace example that we have started with, and these are one of the passes to the furnace. So this is a furnace, right? And this is one of the line through which some natural gas or some other gas is going towards the furnace, and this is another line. So this is pass 1 and this is pass 2, right? Now, it is very important that sufficient amount of natural gas or the fuel goes to the furnace. Otherwise, there can be over temperature or under temperature of the furnace. That may hamper safety, reliability, and profitability of the plant. So that's why controlling the flow of the fuel to the furnace is important. And how we control the flow? For controlling, we first need to measure, right? So this is the flow meter through which we are measuring. The flow meter is sending signal to the FIC, which is the flow indicator controller, which can be a DCS or it can be a single loop controller also, right? So in this case, suppose it is a DCS, right? And DCS sees the value and there is a set point. The set point is given by operator, right? Operator gives the set point. Based on that, this gives you PB, this gives you SP. Based on that, it provides MB or manipulated variable. This manipulated variable goes and changes the valve position, right? Depending on the flow. So if the flow is going more, the signal MB will become less and this will try to close the valve, right? On the other hand, when if D is less and you want to increase it, then valve will open, right? So depending on the situation, this valve will open or close to a certain amount. And this is how this closed loop is being done. Now here you see the configuration is very simple. First, you need to have a sensor which measures your process variable. So in this case, this is FT. So first you have a sensor here, right? Then it goes to FIC, which is your flow indicator controller. And then it goes to your final element. So this is basically your final element, right? So what are the basic three components of a closed loop control system? Sensor or transmitter, controller, and the final control element. So this is how a closed loop is basically formed and depicted in the P&ID. Let's take another example. So in this case, there is a vessel and the vessel there is an inlet line. So this is your inlet and this is your outlet line, right? And our primary goal is to maintain the level of the vessel, right? Because if there is a high level, there is a chance of overflow from the vessel. So if there is overflow and if the liquid is hydrocarbon or any toxic material, then it is a basically safety hazard, right? It is a safety hazard. Also, maintaining the proper level is required for some operational reason, right? Or maybe there may be some financial consequences because if the outlet is connected to a pump, here if there is a pump, right? And if there is a low level here, then what will happen? At a very low level, this pump will go into the dry run and pump will damage, right? So this also we don't want. So because of all this reason, the uh, level of the vessel is needs to be maintained. That is our primary concern. And for that we have a closed loop control. How the closed loop control is configured? So first you will need to measure the level, right? So here the level is measured through this LT, right? This LT01, and the output it basically generates you the PV, and operator gives you the set point. This is given by the operator, right? This is given by the operator. Operator gives you the set point. Suppose the operator gives you a set point of 50% or 60%, depending on the situation, it may change. And so, and LIC basically checks the PV, checks the SP, and calculates the MB value, right? So MB value then goes to this valve. This valve is a final control element, right? So if suppose the level is now 60% and your set point is 50%, so you basically need to reduce the level, right? To reduce the level, you need to open the valve more, right? So if the valve opens more, so suppose earlier it was 30%, now it was going from 30 to 40%, 30 to 40%. So when it becomes 40%, again suppose the level is came down from 60 to 55%, right? Or it goes to say 45%. Now when it is 45%, now your set point is 50%. So basically your level should increase now. How you can increase? Your outlet flow should decrease. So from 40%, suppose you decrease it to 35%. Now when you decrease it to 35%, the level maybe now goes close to 49% or suppose 51%, and slowly you have given a set point and level adjust to it, right? Like this, like a first order system, or it can behave like this. Slowly it goes to the set point, right? So if you want to know more about how this twinning process for the BPC system works, there is a whole different course process control system. You can check a look of that. So link to the lectures are given in the description. Okay. So hope the concept of BPCS is clear to you now, and what are the different components of the BPCS that are required to be shown in the P&ID is also clear to you. So that's all from this video. Thank you. Thank you so much. Actually, there is another uh, temperature loop is also there. So this is very simple. I think you can understand on your own, but still, this is basically giving you an heat exchanger, and in the heat exchanger there is a medium that is getting heated here. Sorry, cooled here through cooling water. So you can see what is happening basically here. You have a medium that needs to be cooled, right? Suppose it is at 100 degrees centigrade and you want to cool it to 90 degrees centigrade, right? And the cooling is done through the cooling water. And how, so this is very important because this temperature needs to be controlled. Otherwise, there in the downstream piping may be affected or downstream process may be affected, right? So how it is done? It is there is a temperature which measures the temperature, so which gives you the PV value. Then operator gives you the set points and the TC generates you MB. And based on this MB, this valve opens or closes, right? And that is how the temperature is maintained. So this is a basically temperature loop. So basically all the cases you can see there are three things. That is, one is your sensor or transmitter, then your DCS, or your controller, and the third thing is your final control element. These three things are necessary to complete a final a BPCS or basic process control loop. This generates PV, this generates MV. Okay, so hope the concept of BPCS is clear to you, how it is represented in the P&ID is clear to you, and you have understood the basic examples of that, basic industrial examples.